Hello, everyone, and welcome to this month's installment of NEEP's Ready, Set, Scale series. I'm Cornelia Wu, Senior Manager, Codes and Standards. This webinar is being recorded. We will be enabling the closed captioning, and in order to disable this, you can go to the lower right-hand corner, and we will be sending the slides and recording to everybody. You are all muted. Please type in your questions in the Q&A. If you have comments or discussion or collaboration, that can go in the chat. And we have an antitrust statement. Participants shall comply with competition law requirements and shall not enter into any discussion, activity, or conduct that may violate any applicable competition law. Thank you to our allies who you see listed here. A sincere thank you to all of you. We could not do this without you. And a big thank you to our funders. Your support of our projects and initiatives helps us work towards our mission. First and foremost, NEEP is a regional organization. We cover 12 states from Maine to West Virginia, plus Washington, D.C. We work closely with our state partners and share knowledge and offer technical assistance to advance clean energy goals. And the NEEP Summit is coming up. It's June 13th to 15th in New Haven, Connecticut, and it's at the Hotel Marcel, which is itself a flagship sustainability project. Our topic today is remote virtual inspections, or RVI, and offsite construction. This project is funded by the U.S. Department of Energy. We have 3 guests with us today. We have Mike Turns, Performance Systems Development, Mike Brown, Advanced Building Analysis, and Lucas Toffoli, RMI and Advanced Building Construction Collaborative. So some quick definitions. I know we have a mixed audience today in terms of familiarity with this topic. Offsite construction is a construction method where some of the components of the building are at an offsite factory and then they're assembled at the building site. Some form of on-site construction is always necessary, in particular the foundation, sometimes the cladding after the factory assembled parts come to the on-site location. Off-site construction methods include pre-cut lumber, panelized walls, and modular components. So pre-cut is basically a factory that takes lumber, measures it, cuts it, and then labels it together with the blueprint. So it's basically a kit of parts. Panelized systems include SIPS panels. Those are often plywood sandwiches or oriented strand board sandwiches with insulation in between. And those are structural. And finally, modular. This is what most people think of as offsite construction. All the components, including plumbing, electrical, mechanical, most of the finishes, these are all assembled at the factory and then trucked to the job site. This makes inspection at the final building site basically impossible without damaging the work. For instance, once you build a wall, put in the plumbing, the electrical, possibly, and then the insulation, once you put that drywall on and send it to the site, no inspector at the site can take a look inside. So this is where RVI comes in. Also to note that manufactured HUD housing, what you would think of as mobile homes, they are not covered under offsite construction because they fall under different federal regulations. As far as RVI, they're an inspection method that allows inspectors to use technology such as video to conduct inspections without needing to be physically present. Usually electronic plan permitting at the time of application for a building permit, that's usually a prerequisite. Sometimes drones are used, but these are subject to FAA regulations. And the COVID-19 pandemic limited ability to perform on-site inspections due to social distancing requirements. As a result, this did drive the need for RVI. Next slide, please. At the beginning of this project, which is a 3-year project, we're concluding in a few months, and this webinar is part of a presentation of our findings. A joint survey was conducted in 2021 by the project team in collaboration with the International Code Council, or ICC. And we targeted responses from jurisdictions and contractors. You can take a look at this website. Again, slides will be issued to everybody, and there's a brief that discusses this survey in more detail. Next slide, please. So out of the survey, we found that contractors are basically not as aware of the fact that their jurisdictions were already offering remote virtual inspections. You see under the survey of jurisdictions that there were a total of 41% that were offering RVI, and the contractors, there were only 18% that were aware of this. Next slide, please. And here the question put to the jurisdictions was whether they would continue to conduct remote inspections and electronic permit reviews after the pandemic is over. And you'll see that 41% said yes. If you take a look, you'll see that the dark gray and the light blue correspond with the south and the west of the country. This is basically the areas that were already using it the most before the pandemic. Next slide, please. This is a graphic in promotion of a toolkit that's in development by the ICC. This is just a sampling of the checklist. The checklist will basically be issued in an Excel format, and it comes through. You can see there's general, floor and frame, final inspections, renewables, and for existing buildings, there are checklists for all of these categories. And they start with things like mechanical, continue to finishes. And this is something that is not only great for a thorough RVI inspection, but also for regular on-site inspections. Next slide, please. So the efficiencies of off-site construction are that it is fabricated in a facility under controlled conditions. In terms of sustainability, this means that materials don't have to be left outside. There's less exposure and subsequent possible mold formation. The work at the building and the factory can proceed simultaneously. As I mentioned before, you can be digging the foundation and pouring the foundation and creating the walls in the factory at that time. And finally, precision cutting in the factory can lead for tighter seals for air tightness. One of the challenges that we've been looking very closely at is that the factory is often in a different jurisdiction or state than the authority having jurisdiction, also known as the AHJ. The AHJ is always local to the job site. And under these conditions, AHJs often hire third-party inspectors, that is, inspectors that are not employed by the AHJ directly. These third-party inspectors visit the factory. Alternatively, they can use RVI with or without the use of third-party inspectors. Next slide, please. So you'll see from this graph, we've pulled data from the US Census Bureau, the census that was taken in 2020, and you'll see that modular and other off-site panelized and pre-cut methods only make up about 3% of the entire market of off-site single-family homes completed in the US. And you can see it's about half and half, modular and then pre-cut and panelized together. So there's a huge opportunity here to increase the use of off-site construction, and the use of RVI can help promote that. Next slide, please. You can see from this schedule that the time savings is actually, builders have said that this is their biggest incentive to using offsite construction. Where the two blue boxes are doubled up, you can see that the site development and the foundations are happening at the same time as fabrication in the factory. And then the install and the site restoration happen much quicker. If you could go to the next slide, please. And the International Code Council and the Modular Building Institute work together to provide standards for offsite construction. There's generally a need for universal guidelines, especially for jurisdictions without statewide programs. And these model standards are there for this purpose, and we're hoping that this will increase the uptake of offsite construction. So you can see 1200 is for planning, design, fabrication, and assembly. 1205 is for plan reviews and inspection. And 1210 is still in development. It's for mechanical, electrical, and plumbing, as well as energy efficiency and water conservation. Next slide, please. And this is our project website. And as I said, the slides will be distributed, and you can go here, and we have multiple resources developed over the course of this project for both offsite construction and RVI. Next slide, please. And you can reach me at this email. Next slide. Next, we have Mike Turns. He is the Director of Energy Code Services for Performance Systems Development. He manages the implementation of the Mass Save Codes and Standards Compliance and Support Initiative New York Energy Code training funded by NYSERDA, Pennsylvania Energy Code training through the Pennsylvania Department of Environmental Protection, and Energy Code support services to the Delaware Department of Natural Resources and Environmental Control. He is an expert in the IECC, the International Energy Conservation Code, and has developed and taught numerous training programs in several states under a variety of code versions. Mike serves on the board of the Northeast HERS Alliance and is the chair of its Energy Codes Committee. Welcome, Mike.
All right, thanks, Cornelia. So yeah, Mike Turns with PSD, and I guess we might as well just go to the next slide. I'm the director of our Energy Code Services Division. Our one-sentence summary of the company is here. We combine building science with technology to help utility companies, program implementers, and building performance professionals achieve energy savings. So we're an energy efficiency program implementer. We have a lot of training and education that we do, building science and efficiency related. We have a software division that supports energy efficiency programs, an engineering group that does a lot of primarily energy modeling type work. So that's PSD in a nutshell. Next slide. So we've done some training on this subject as part of a broader training regimen that we're doing, funded by the U.S. Department of Energy and their state energy program, as allocated to us by the Pennsylvania Department of Environmental Protection. So a shout out to them. So I'm going to provide kind of just a little bit more background on RVI in general, not necessarily focusing on the offsite element of it. So Cornelia mentioned some of this, but reducing human contact, this, it wasn't invented because of the pandemic. The idea had been around, but it really did start to come into its own and really gain traction for obvious reasons. So reducing human contact is one of the benefits. Something that is a little more long lasting in terms of the benefits of reducing travel time, the expenses associated with travel, and the greenhouse gases and other emissions that are associated with that travel time. I'm in Pennsylvania. It's a pretty rural state, so drive times in the rural areas can be pretty long. And a lot of the code officials, especially that work for some of the third-party inspection agencies here, spend huge percentages of their time in the car. And it can also be an urban thing. We talk a lot with the city of Philadelphia and their inspectors, and getting around the city comes with its own challenges as well. Other potential benefits: scheduling flexibility. If you can cut out that drive time, then you have more time to schedule inspections, and you can be perhaps a little bit more what's the word? You can sort of strike when the iron is hot. If there's a tight inspection window, like for example, insulation is being installed, the builder wants the drywall coming in and putting that up as soon as they can right after that. So they're often on the heels of the insulator. So if you can come in and strike quickly and grab that insulation inspection, that's going to make the builder happier as well. So being able to do a quick strike is another potential benefit. Next slide. Challenges, and I don't want to underestimate the challenges. I think traction has been relatively slow, at least in terms of the conversations that I've had here in Pennsylvania. But there's the video conferencing learning curve. I think everybody has gotten better at that over the course of the pandemic, but there's still a lot of different platforms, and utilizing it effectively out in the field and for the code official in the office still comes with its challenges, at least in the beginning. Internet connectivity, and this might be the biggest one. We were just taking videos for training for the course that we were developing, and we struggled with internet connectivity and doing that. I'm in State College, Pennsylvania, so it's sort of rural Pennsylvania, but it's also a university town, so the internet is not a foreign commodity here. But even in State College, we had some issues with internet connectivity, especially when you get down into a basement and you're surrounded by concrete, for example. So that is going to be a challenge, and is a challenge. Job site noise is another thing to be concerned about. You know, you can tell the subcontractors to take it easy for a while you're doing it. Noise canceling headphones. So, you know, there are solutions to that. And then communicating the inspection requirements in the process. It's a different thing than just showing up on site and the code official just walks the site. You know, there has to be this two-way communication between the builder or their representative on site as the code official kind of guides them around. Next slide. Right, so it did enter the national conversation, you know, mainly during the pandemic. So it was covered. I don't know that there was any coverage of it at the DOE conference that just happened, the National Energy Codes Conference, but past conferences have featured sessions or tracks on this. ICC, NEEP, and MEA had done survey and interviews, as Cornelia referenced. And ICC has resources out there. You can get them on their website. There's the URL down below, but they have recommended practices for RVI. So they've done a fair amount of thinking about this. Next slide. You need to kind of decide on your video conferencing platform that you're going to use, or have a list of acceptable platforms. And then, you know, if there is a list, the code official is going to have to be familiar with how to use each one of those. And then the builder's representative is going to have to know, you know, their platform of choice, or maybe the code official is going to dictate what platform they use. So there's got to be some communication, you know, up front to even know what platform you're using. Next slide. So the general idea is the builder's representative is going to be the eyes of the code official, and then the code official is going to guide the builder's rep around the site. So this little code official here is not looking so hot, but you can see how he's sort of controlling the builder's representative around the job site. Next slide. So more realistically, this is kind of what it would look like. The job super on the left is showing the site. They're the eyes of the code official, as I said. The inspector on the right is in the office, and she's there, you know, just looking at her screen as shown to her by the builder's representative. And then there's little things like, normally when you're FaceTiming with somebody, your image is small and their image is big, and you want to toggle that because the job super wants to see what they're showing the code official, not a big picture of the code official's face. So just little details. Next slide. Battery life is another big issue. This can really chew up, you know, when you're doing a video conference, it does eat up the battery quickly, so you need a full charge. Internet, as I mentioned, making sure that there's time. I guess that would be for any inspection, really. Everybody being aware of the technology. So this is a list of things that to make sure that, as ICC refers to the builder's rep as the customer, that you need to get them prepared for. So photo capturing, if that's going to be a part of it, maybe there's something that needs to be fixed and you want to document that. So you can ask them to snap a picture, or maybe the code official could do a screenshot. And then they'll want to prepare the site and minimize job site noise. Another thing that's not on this list that I should mention is I think safety is a big issue here. You know, somebody walking around looking at their phone instead of looking where they're walking on a job site is a potentially hazardous situation. So making sure that there aren't obstacles or hazards that going to create a fall or something like that. Next slide. So I recommend that they have some kind of regular process. And I recommend this for any inspection, but I think it's especially important for RVI. But you know, start out at the street, you need to confirm the site address and everything, so you know you're at the right project. Take a look at all the elevations, make sure the house looks generally like it's supposed to look like on the plans. When we went out for one of our training videos, they had added a window, for example, which may or may not create issues with compliance. And then move inside and have a kind of standard pattern for going through the house, starting at the top and working your way down, or vice versa. moving clockwise around the floor, around each room. But you really need to get a full scan of everything, because it would be easy for the builder's representative to not show you something that they didn't want you to see. That's another challenge of this whole thing. And we also recommend that the code officials use a checklist to help guide the builder around the site. Next. So just example, we've developed checklists for Pennsylvania. These could be used for on-site or off-site inspections, but we just have them grouped by the phase of construction with the energy code requirements grouped that way. Next. And just an example of what this might look like out there. Here they're identifying the site. So they have a iPad that they're holding up and showing the code official. The code official is viewing that on their own screen, and then they're communicating back and forth through the video conferencing platform. Next slide. So they've identified the site, they move up, they're going to take a look at the foundation. Code officials noticing that this doesn't look quite right. I won't get into the detail about that, but so just to graphically show what the process looks like. Next slide. This is just a screenshot. I had like a 20-second video, but it's a technical challenge for the webinar. So, this is a screenshot of somebody walking me around the house as I'm pretending to be the code official, and we can see how the bats have not been split around the wiring there, for example. So just to give you some sense of what it looks like out there in the field. And I think that's all I have. Oh, there's a summary, but I'm probably over my time, so I can skip that. All right, there's my email if you want to get in touch for any reason.
Thanks so much for joining us, Mike. That was really useful, sort of on the job type information. I know you do a lot of training in this, and thanks so much. We'll come back to any questions after Mike and Lucas have gone. Next slide, please. I want to introduce Mike Brown. Mike Brown has been a HERS rater since 2007 and is the principal and founder of Advanced Building Analysis. Mike and the ABA team are an Energy Star partner who help builders of new single-family and multifamily homes cost-effectively meet the challenges of higher energy efficiency standards. ABA consults with architects and builders to improve building energy efficiency to meet or exceed program goals established by the EPA's Energy Star, Mass Save, LEED, and Building Code Consultation and Verification.
I should be unmasking myself now, right? Hi.
Yes. Hello, Mike. Nice to see you.
Very good. Very good. That was just thank you. Thank you for the introduction. Next slide. Great. Well, let's just jump right in. My background is that of a HERS rater, and a very narrow look at RVI perhaps, but got a history of it and a history of working with modular plants. So I have just a handful of slides here. We can go through them pretty quickly, but I want, this is my perspective of having done modular plant inspections as a HERS rater. In Massachusetts, of course, HERS ratings are now required for most of the new construction in the state. So when that happens in Pennsylvania or New Hampshire or Maine or even in Quebec, we need to figure out how we meet the HERS rating requirements and the requirements of other programs that use HERS rating. So that includes Mass Save, obviously. It includes the Massachusetts Energy Code. It also includes Energy Star or LEED or the DOE Zero Energy Ready Homes program, National Green Building Standard. All these other programs sort of are built off of HERS rating and will have their own variations of requirements for inspections. So it is very complicated to figure out why a HERS rater might be showing up on a job site sometimes. They might be involved with any one of these other programs. And the first thing everyone needs to ask is, why is the HERS rater here? What are they doing here? What program requirements are we talking about this time? So as I go through this, I want to talk about, first and foremost, just the core HERS rating requirements that we have, and then I'll be mentioning some other requirements that might ride on top of that. This is a picture of a plant in Maine that we've worked with a lot. And we started working with modular plants almost as soon as I started HERS rating in 2007, trying to figure out how we're going to get these insulation inspections in particular done when they might be happening 8 or 10 hours away by driving. So next slide. The first thing we can do is find a local rater, so we don't have to drive out there and do the inspection ourselves. And that was one of the early approaches. We would find people local to a plant in Maine or Pennsylvania. Often the plant would help us find somebody. Sometimes we would try to find somebody. We would get a HERS rater to actually visit the plant and do the inspection. But that wasn't always possible. And sometimes we get projects who come to us and just never got this organized in time. So next slide. Sometimes we just don't get a chance to perform the unplanned inspection. And in the HERS rating process, we can accommodate that by simply saying, all right, we didn't verify any of that. We have to assume that whatever insulation might have been there is not well installed. So what we call grade 3 insulation, not properly installed, is what ends up in the HERS rating. This can mean a difference of a few HERS index points that may or may not be a problem for the project. So sometimes a project might end up still passing all of the requirements with grade 3 insulation. So that is a possibility, but that's not a preferred option, right? We always want to have a chance to verify the insulation is well installed. But to be clear here with HERS rating, the grading of insulation needs to be done by a HERS rater. It's not something that can be done by someone else. Next slide. Okay, so here's another program that uses photo documentation. One of the first programs where we got clear guidance on photo documentation was Lead for Homes. And they have it's a 2 or 3 page document on everything you would need to do. So we started using that. And I still use their guidelines when I'm trying to share with somebody what we might need during this COVID period of time. These are just well presented. So the Lead for Homes photo documentation guidelines are just good guidelines for any project. And I think Mike already talked about these types of details. So I'm going to just go next slide. And then, more about the history of how we've managed things in modular plants. At one point, modular plants did have an Energy Star plant certification possibility. And we had plants come in and out of compliance with that plant certification. But that would have meant that in the plant itself was certified by Energy Star to do the insulation grading and all the quality assurance required for an Energy Star project. That was great when a plant did it. It was actually hard for them to maintain it, and we were always tough on them to try to make sure that they really were certified. When they said they were certified, they weren't always. To be clear now, though, that modular plant certification is no longer available. What can be confused with it is the manufactured homes certification of an Energy Star plant. So that, again, that's a mobile home, very different from modular construction. Next slide. So what else can we do? This is what we've been doing for a long period of time. If we can't get the local HERS rater to do the work for us, we'll try to establish sampling protocols. And all these different programs, again, have their own sampling protocols, often building upon each other's requirements. Sampling requires a history of success before we start doing it. So, full inspection for a period of time. It requires an in-house quality assurance process that is going to happen regardless of whether the sampled inspections are happening on a particular unit or not. So when we help set up a plant for modular sampling, we're going to go there and be there for a period of days, maybe even a week, as we establish that their normal practice on that project is meeting all of the requirements. And this will happen on large multifamilies in particular. So a large multifamily project going through a plant might take 60 or 100 boxes. They're going to come down the line at different periods. And the way the boxes move down the line means it's hard to see everything all at once. This is a continuous assembly line, and it doesn't you don't get a chance to stop it. It's hard to stop. Cost effectively, that would mean the plant would have to grind to a halt. So how do you manage that? Well, the rater, again, is there for the first week, helping establish that there are checklists and a quality assurance process being used by the in-plant staff. And the rater can help establish that, help get that going. After that's going, the rater needs to establish that that's working for a period. 7 in a row is the ResNet standard. So 7 in a row of a thing that needs to be observed need to be correct before sampling can begin. So maybe a rater might need to be there for a week, just poking their head in when appropriate on the shop floor, when the QA people say something is ready for inspection. And that's the key. The QA people need to be confident that they've completed their part, then they show the rater that it's ready. Once that's all accomplished, then it can start sampling. And that might mean the rater would then need to revisit periodically in a way that they can put their own eyes on at least 1 box out of 7 that goes down the line. And I'm talking about boxes now because that's the practical way to do sampling in a plant. Sampling protocols are written in terms of homes. We look at this number of homes, but when you move that into a modular plant, the only practical thing to do, because they don't come down the row, is 1 box after another until you have a complete home. The boxes may be all mixed up. So the practical thing to do is look at them as boxes. Next slide. Okay, now all that leads up to our starting to use remote verification protocols. These only started with COVID. In the HERS rating world, and those are ending soon. So I don't really want to dwell on those too much, except to say that I think they've informed the RVI work that you've seen, and we have some experience with that. It can work well. In fact, one of these sampling projects where we spent time in site in the factory setting up their quality assurance process happened right at the beginning of COVID, and we quickly shifted into the sampling being done remotely. And because we had been there first, we were very familiar with the site. We were very familiar with the people involved in the in-house quality assurance. That worked really well. Next slide. These are some of the requirements from the COVID protocol for HERS rating. Just again, similar to what Mike provided, some guidance on how to prep people for a remote inspection. That's very important. And next slide. A little bit more about how you go through a project, and context is everything, right? We want to make sure people aren't just sending us photographs of a detail when that detail could be anywhere in the world. First thing you need to do is just simply establish that you are where you think you are, and get people to slow down, the builder to slow down and make sure everything is verifiable. In the modular plant, same idea. There needs to be a way of tracking it, each box that goes down the line. And when we have a modular plant set up to do this, they'll have a clipboard or something like that that goes with each box with the checklists that they're verifying on site. And I'm going to be asking them to show me their checklists, as well as show me all the items on the checklist when I'm looking at a individual project for sampling, like we discussed. And I think that's about it.
Thanks so much, Mike. I do have just a quick background question. If you could explain what HERS stands for,
Sure.
And maybe give a sense of what is a high number or a low number for that rating, and perhaps an example of what one of the states you've worked in has as a requirement.
Sure, of course. So often when I'm presenting in a room full of people live, I'll ask people to raise their hands and see how many people know what a HERS rater is in the first place. So good way to establish where we're starting from. But not being able to do that here. HERS rating is the home energy rating system established by the mortgage industry in the early 1990s. It's a way to cost effectively finance energy efficient improvements, whether it's new construction or existing homes. It was never really adopted by the mortgage industry in any significant way. And instead, Energy Star Homes latched onto it. And then later on, utility funded efficiency programs latched onto it as a great way to quantify the types of improvements that they were encouraging and make sure you had a great inspection protocol and modeling protocol to go along with all this. So that's HERS rating. HERS rating is used is also another word for it is the energy rating path of the IECC. In Massachusetts, HERS rating is exactly as used as an equivalent to the ERI. The energy rating index is equivalent to the HERS index. And that was important in the 2018 IECC when the ERI calculation went askew, the handling ventilation very differently from HERS rating. So anyway, Massachusetts is where most of my experience is with HERS rating.
Thanks so much. And we'll come back to you once we have everybody together for more questions.
Sure.
Next, I want to introduce Lucas Toffoli. Lucas is a principal in RMI's carbon-free buildings practice. He leads the Advanced Building Construction Collaborative, which is in cooperation with the U.S. Department of Energy. He co-leads RMI's Realize initiative. The collaborative works with a diverse range of building sector stakeholders to accelerate the development and adoption of advanced building construction, industrialized construction solutions for building decarbonization. The collaborative's mission is to drive speed and scale in decarbonizing the U.S. building sector while improving affordability, resilience, and equity. Lucas's prior experience spans real estate development and construction management, strategy consulting for global and startup life sciences clients, architecture, building operations, and coaching. He has worked on 3 continents and in 4 languages. Welcome, Lucas.
Thanks, Cornelia. Thanks very much for the introduction, and thanks for having me today. Happy to be here talking a little bit about offsite construction in particular, and I'll touch on a little bit of the implications relating to remote virtual inspections. But Mike and Mike are really your experts in the room here on RVI. So I'm going to be taking a little bit of a step back and talking more generally about industrialized construction and the opportunity there. Next slide, please. So where we find ourselves right now is in this dire need to address multiple buildings related challenges simultaneously and rapidly. And in a moment, I'll talk about how industrialized construction fits into that. So we all know that we are kind of in the midst of potentially catastrophic climate change. Buildings are a big driver of that, both on the embodied carbon side, but especially on the operational carbon side. Inefficient homes and a need for more homes and more better homes are really creating a drag in terms of energy waste and cost or dollars spent on energy, as well as high housing costs. And a lot of those high energy burdens really accrue to some of the most vulnerable population in the US and in other parts of the world. And then in parallel with this, we've had a kind of flat or declining labor productivity over the last several decades, which makes it hard for us to appropriately and quickly respond to these other kind of systemic issues in the building sector. So that leaves us in a difficult situation, as I'm sure many of you are aware. And again, we see the combination of industrialized construction and building decarbonization strategies as a potential solution here. Next slide, please. So what does that look like at a high level? And maybe this sounds a little trite, but we need to improve what we build and how we build it. And that's what we call advanced building construction when we talk specifically about this intersection of energy efficient building decarbonization and scalable industrialized construction methods, or IC. On the energy efficient side, we're looking at, of course, electrification, so that we're electrifying end uses and avoiding direct fossil fuel emissions or fossil fuel combustion. But the energy efficient part of that also brings a lot of additional benefits. Certainly utility and maintenance savings in a lot of cases, increased thermal and acoustic comfort. So this is huge, especially in the Northeast, where NEEP is most active, and you have a lot of old housing stock and cold weather. also hot weather sometimes. And then improved indoor air quality and health through ventilation, through the avoidance of fossil fuel combustion. Better resilience, this is kind of part B to the increased thermal comfort, but it's more of the acute version of it when you have extreme weather events, and especially if you have like a power outage during an extended extreme weather event. And we've actually seen that in even parts of the country that maybe historically didn't feel like they were at risk of this, like in Texas a couple of years ago. And that's really emphasized the need for more passively efficient buildings. And then, of course, reduced emissions. That's both for the climate, as I mentioned, but increasingly for compliance. And more broadly, although builders may not care as much about this directly, the benefits that can accrue to the electricity system when you have lower and more managed loads in buildings. And we need to do this faster. We need to do this in a more scalable way. And that's where industrialized construction comes in. There's the opportunity for higher productivity and faster delivery. And that higher productivity part is not about replacing people with robots. It's about recognizing that even if we double down on workforce development in the construction industry, the trend there is kind of going in the wrong direction for the amount of capacity that we need to build and the amount of output that we need, both to close the housing gap and increasingly to retrofit our existing stock. So the point of higher productivity is to do more with the somewhat limited labor force that we have, that we'll have for the foreseeable future in the construction industry. And then there's other benefits like reduced disruption, greater certainty around schedule and budget, better precision, quality control, reduced waste, which can also reduce embodied carbon, and then improved safety, because you don't have so many things happening all at once, stacked on top of each other in a uncontrolled job site. Next, please. So I see industrialized construction includes off-site construction in a physical sense, but it also includes the idea of streamlined processes and digitized workflows. So that's really where there's this kind of dovetailing of the physical off-site construction process and processes like remote virtual inspection and digital tools enabling inspections. Next slide, please. So different prefab or offsite approaches vary in the level of work completed offsite, and that has implications for inspections. So kind of two major categories are open systems and closed systems. So with open systems, you have simpler prefab with greater use of local or on-site labor to complete projects. So this is where you have kind of partial or open wall panels that are being built at the factory and then delivered to the site, and having various levels of finishing at the site. So that might mean that they come, with insulation, and they need MEP and finish layers and cladding and things like that. Or they may, even come without insulation and be essentially just kind of a prefabricated shell of a panel. In most cases, open systems can be inspected on site, similar to conventional construction, although you can still employ on-site remote virtual inspection if AHJs allow it for the other reasons of efficiency and potential savings that Mike spoke about earlier. With closed systems, these can be both panelized or volumetric modular. More work is completed in that controlled factory setting, and in most cases, these will require in-factory inspection because there are different layers of work done in the factory that kind of obscure each other. And as other Mike said, if you can't see it, then you have to kind of assume the worst about a particular feature of the building. One thing that is pretty interesting and is done a fair amount in the UK, where they have somewhat developed industrialized housing industry, is to do kind of a sequential panelized to modular setup in the factory, where you have a panel line that is doing these kind of subcomponents, and then in the same factory, you're assembling those panels into a volumetric module. And in that case, there can be this pretty clear point in the middle of those two lines where you can have a good spot for a factory-based inspection. So that's a way to get potentially greater efficiency in the fabrication process and also in the inspection process. Next slide, please. So as Cornelia mentioned at the beginning, the International Code Council, in cooperation with the Modular Buildings Institute, released standards for offsite construction about a year ago, or a little more than a year ago. So these are 12 standards, 1200 and 1205, with 1210 currently under review and comment. And so 1200 is more focused on the practitioners and the roles of architects, manufacturers, CMs, GCs, and 1205 is more about the framework for inspections, whether in factory or on site, as well as third-party plan review and inspections, and roles of AHJs. So it's more for the code official side. And I'm going to spend on the next slide, please, a moment on a kind of case study of this. Salt Lake City was one of the first jurisdictions to adopt ICC-MDI 1200 and 1205. And this was in response to a common challenge among urban areas where Salt Lake City has been facing a shortage of attainable housing. They had regulatory barriers where historically their city officials had to inspect projects directly and in the jurisdiction. They weren't allowed to leave the Salt Lake City jurisdiction geographically. And Utah also doesn't have a statewide regulatory program for offsite. About 2/3 of states have that in some form, and Utah is not one of them. And so the City Council of Salt Lake City took action by being a leader in implementing these new standards. And this allowed the use of third-party inspectors to overcome that issue where Salt Lake City inspectors couldn't leave the jurisdiction. Obviously, in many cases of offsite construction, the factory facility is not co-located in the same jurisdiction as every job site that factory is going to be serving. So this is going to be a common challenge with offsite construction. And within the first year of adoption, Salt Lake City saw a substantial increase in housing deployment, especially with ADUs, which has been a focus of Salt Lake City to kind of densify some of their housing. And they're now considering some additional zoning changes to further increase deployment. So next slide, please. I think this is my last. Feel free to contact me or visit our website, advancedbuildingconstruction.org, and our contact page there. If you have any questions about industrialized construction, offsite, or the ABC Collaborative. Thanks so much for your attention and looking forward to the discussion. Back to you, Cornelia.
Thanks so much, Lucas. If we could have Mike and Mike back, we can do some Q&A. As I mentioned before, there's we have the chat, which is for comments, but there is a Q&A option if you want to start putting questions in there. And I'll kick it off. Basically, as we've discussed, the use of RVI can have a positive effect on energy efficiency. And Mike, you touched on this a little bit with the June expiration date of RVI for HERS raters. Where do you see the use of RVI going, and how do we address barriers to increase its use? And for Lucas, if you could expand this into the use of offsite construction as well.
Yeah, within the ResNet standards world, there is a effort to look at extending some of the remote verification opportunities we have right now, which are expiring. It does make a lot of sense, but that's going to have to go through a standards process before it's accepted. Yeah, I don't know much more to say about it than that. We hope to be able to do it more. There is still an opportunity for quality assurance review of HERS raters work. All HERS raters have their own field work reviewed by another person called the quality assurance designee. That some of that work can continue to be remote, but yeah, that's expiring on did I say July 1st? Yeah, very soon.
So I can jump in here on the offsite construction side. I think it has to go in the direction of greater growth, because I don't see how we meet our housing challenges and our decarbonization challenges, including for existing buildings, without a more modernized and industrialized construction industry. And again, when I say industrialized construction, that includes some of the physical processes, but also some of the kind of processes like remote virtual inspections or other technology enablement. And in terms of addressing the barriers, I think a lot of this starts kind of very early in the pipeline, or very upstream. There's a need to incorporate the kind of understanding of the processes and the technology tools from the very beginning in workforce development and training. And I know Mike and Mike are both involved in some training programs. So it's great to have folks like them who are, kind of inculcating the workforce with tools like RVI. But that's also true of having, construction education cover not just how we've been doing construction for the last 100 years, but also how some companies are starting to do construction and how we could do construction differently. And I think that will also help address some of the issues we're seeing with a construction workforce that's aging out, in part because a lot of younger folks right now don't necessarily see a future for themselves in the conventional construction jobs. But if they can be framed as a modern technology enabled pathway that's also perhaps more inclusive of different kinds of demographics that have been traditionally underrepresented in that industry, that's a real opportunity to help the industry evolve kind of at the pace of the evolving population as well, and kind of grow in the way that it needs to grow to meet all these other big challenges we have.
From my perspective, I don't want to sound overly pessimistic, but I mean, I think it's going to be pretty slowly adopted on the code official side in most areas. I mean, because of some of the challenges that we talked about with internet connectivity, there's also just a certain level of, I think, trust that you need with whoever's on the other side of the camera. And then just any kind of policy change like this with the code office takes time and effort, and there's always just a certain amount of inertia there to do something new and come up with your system and policies and make that work. So I just think they're so busy as it is, like taking on a new thing like this could be challenging, even if it ends up saving them time in the long run. There's still that initial investment of time to get things set up to do remote inspections. So yeah, that's kind of my perspective. A lot of code officials have talked about kind of starting with a limited use of it, in terms of maybe you've already walked the site once and there was a violation,
right,
and you need to do a reinspection, and then you could do a virtual reinspection. So I think maybe they'll start slow with some of these more specific types of, or limited uses of it, and it'll evolve. But I personally think it's going to be a relatively slow evolution.
And I'd like to add something just about how best to achieve some good quality in modular construction. I do think it's important for the first visits with people in a plant to be in person. I think the verifier is going to learn a lot by visiting the plant in person, and do a better job of remote inspection later on, if that's a possibility. But the most critical point in modular construction, in our experience, where most of the problems happen, it's going to be in setting of the boxes, because the setting of the boxes happens so fast and furious that damage can happen. Good air sealing might not happen, and we've seen major difficulties result. We've seen ventilation ductwork, dryer exhausts, crushed by the people running around on tops of boxes and as they're setting a multifamily building, and just lack of the full air sealing requirements being met between boxes. So that's my advice is, as you're trying to manage that process, That's the process that needs the most scrutiny. And it will be rushed. It's going to be chaos. That's the chaotic part of it all.
Thank you. I'd like to follow up with a question about, I know, Lucas, you had talked about the ICC MBI standards as well. How much of a hurdle it is that there haven't been universal standards across various states, and whether other jurisdictions are looking at Salt Lake City, and perhaps is that encouraging them to take a similar tack?
Yeah, I think, I've seen the Salt Lake City case discussed in a number of different places. So it does seem like it's, kind of a lighthouse or leading case that's being looked to in that way. I think the ICC MBI standards kind of provide an opportunity for at least part of the the standards that are needing to be met by offsite construction to be consistent across jurisdictions. Obviously, that's not going to happen anytime soon for energy standards because every state is a little bit different there. But even if some of the process expectations are consistent, that is it provides a potential for economies of scale and for sort of continuous improvement of replicable processes, which is a really core element of having cost-effective and also high-performance offsite construction. So I'm optimistic that that the standards will have a positive effect in that way. Although going to a point that Mike Brown said, a lot of these things have to go through some kind of a standards approval process or a jurisdictional approval process, and that looks different in different places, and it does take time. I do think that there are increasingly things that are maybe pushing towards a tipping point, at least in some jurisdictions where there's a shortage of inspectors, a shortage of housing, a pressure on the climate and energy side, and then here come ICC and MBI and say, hey, we kind of package this thing neatly for you. How about you take a look at that? So maybe I'm overly optimistic here and look to Mike Turns to add some cold water of reality on this, but I just feel like we're getting to the point where they kind of can't ignore these opportunities and these tools much longer because the long-term and even medium-term benefits are so great, even if there is a little bit of that initial barrier to adoption. And some of that initial barrier can maybe be overcome as you have new folks entering both local and state politics, as well as inspectional offices, construction sites, construction companies. And if they're coming from their training with this knowledge and these tools more inherent to the way they think about things, that's an opportunity to start to kind of change the system from the bottom up and from within. And to Mike's point about these things happening slowly, that's a way that change can start to snowball.
Thank you so much. We're just about out of time, so I just want to thank you so much for coming and presenting and lending your expertise on this topic. I think it's really been educational, and we really thank you.
Thank you.
Thanks so much for having us. My pleasure.